Well, good afternoon, and I'm sorry I couldn't be here today, so I'm just going to go ahead and get started. We are starting off the very first section is going to be our very most foundational building blocks is the type of numbers that we're going to work with. So first unit, first section is going to talk about identifying which number sets different numbers belong to. And each of those numbers that we work with has its own properties, and we'll talk a little bit about their historical significance. But once we establish those number sets, we'll want you to be able to tell the difference between those different types of numbers. And secondly, we want to use the coordinate plane and the distance and midpoint formulas. So distance formula and midpoint formulas are things that you would have seen in geometry. We'll review what those are and how we will use them. So with that, let's get right into it. You should have a notes handout where we'll talk about each one of the number sets. And we'll see that these number sets are not separate sets so much as they build upon one another. And so as we start out, we can kind of see that we've got the natural numbers to begin with. And those are going to be our first set of numbers, and then we're going to add to those and get a bigger set of numbers as the whole numbers. And then we're going to add more numbers to that, and we'll get a bigger set, the integers. And we're just going to keep adding more and more numbers. We're going to keep all of these numbers, and we're going to add to that, and we're going to get the rational numbers, this big set, which includes all of the integers, the whole numbers, and the naturals. But then we're going to have a little bit of a departure. We're going to talk about there are other numbers, real numbers, that do not contain or interact with any of these numbers, and those are going to be our irrational numbers. And when I put those two number sets together, all of the rational numbers plus this other set, this separate set, the irrational, I get what we call the real numbers, and that's every number on the real number line. You're used to seeing the number line. Now, it won't be until Unit 3 that we talk about the complex numbers. That'll include the imaginary numbers. All right, so let's go ahead and get started. So what was the first set of numbers? That's N, and that stands for the natural numbers. And those are like the counting numbers. They're the numbers that come most natural to us. This is one of the number sets that has a distinct beginning. And so we're talking about the numbers 1, 2, 3, 4. When you start teaching your little children to count, you're talking about those numbers. Non-examples would be negative numbers, fractional numbers, decimal, other representations, 0.75. Right? Those are all non-examples. 0 is not a natural number. It's not natural for us to start out counting. How many of those things do you have? Usually we have to have something to count to be a natural number. All right, so let's move on. Then we've got the whole numbers. That's the next set. So eventually we've started to realize that having 0 of something could be thought of as a number itself. And so that's the only additional number that we add in here. So we have the natural numbers and 0. So 0, 1, 2, 3, and so on. The same non-examples that we had over here. Whoa, better make sure that doesn't move. The same ones that we had over here could be used over here, except for which one? Right? Which one? Right there, 0. So 0 is indeed an example of a whole number. So we're going to take that one and remove that. But negative numbers, fractional numbers, decimal numbers, things that are not whole, would not be considered whole numbers. All right, so let's keep on moving. So we've got the counting numbers. We could count something as not having any at all. And then we start to trade. I'll trade you 2 for this, 2 of these for 3 of those, or 5 of these for 5 of that. And when that happens, sometimes people would say, well, I'll give you, if you give me 10 of those, I'll give you 4 today, and I'll owe you 6 tomorrow, right? So now we're talking about debts. We have debts, and a debt is represented by a negative number. Not only do I not have any, but I actually owe some of those to someone else. So these are the integers, and these are the whole numbers, and their negatives. So the whole numbers and their negatives. So this one does not have a specific beginning because it kind of has a middle. We talk about 0, 1, 2, 3, and so on. But it goes backwards, -1, -2, -3, and so on. And so now we've got both positive and negative values. Those are considered to be integers. And like we talked about before, we're just keep adding numbers to the set. We still have things like 3/5, 2/3, 0.5 that are not examples of integer numbers. 2.4. All right, so then we need to talk about what if we do not have a whole amount of something. We don't quite have an entire thing. Then we're going to have fractional numbers. And so that brings us to our biggest set yet, and that's going to be the rational numbers. And you might ask, why don't we use R for rational? So it could be either way. You could use R for a ratio. Notice that this has ratio in there. Or quotient. When you're dividing something up, you're using a quotient. And that's why we have Q here. Q is for quotient, where you take a number divided by another number. A ratio is a synonym for that. So the rational numbers ratio makes rational numbers, or a quotient is our symbol there. And that's any number written A over B where A and B are integers. So we're building up our rational numbers using ratios. So everything so far is included in that because we know that whole numbers, 1 is the same as 1 divided by 1, or 2 divided by 2. 2 is the same as 2 divided by 1, or 4 divided by 2, etc. And so we're also adding in there all the fractional numbers. 2/3, 4/5, -4/7, and on and on. So we have lots of examples there. Now, we also have some decimals because if you remember, decimals are fractions with 10 or powers of 10 in the denominator. So if we have 0.1, that's 1/10. That's a rational number. If I have 0.24, that's 24 hundredths. And any decimal that has an ending here can be expressed as tenths or hundredths or even thousandths. So 0.123 is 123 thousandths. That's not all the decimals. That would be examples. I'm going to go ahead and extend this over here. So this group right here is said to be terminating decimals. And then we've also got another class. 1/3 is written 0.333, or 0.3 repeating. And that is a rational number. 2/3, 0.666, 0.6 repeating. So those repeating decimals are also rational numbers. They can be written as a ratio. So non-examples is much more harder for us to think of in the natural realm. We don't deal a lot with irrational numbers unless we're doing some sort of distance or constructions where I want to use a diagonal. And so you may remember that, we'll see it in a second, that when you do the Pythagorean theorem, you have to take the square root of numbers. And so, for example, a square that has sides 1 and 1, to get the length of this diagonal, it's 1 squared, which is 1, plus 1 squared, which is 1, is 2. And the square root of 2. Well, that is a number that cannot be written as a whole number or as an natural number or even as a ratio of two numbers. So this is what would be called an irrational number. And any radical that doesn't have a perfect square root, that's an irrational number. It cannot be written as a fraction. So those are good examples. There's also other numbers like pi that are irrational. So they don't have a decimal that terminates or repeats. It just goes on and on and on and on. Okay? All right, almost done. We've got two more. Our last two deal with the ones we just talked about. So we just talked about the irrational numbers. Right? Irrational means not rational. So the examples we just talked about, the square root of 2 is about 1.41, etc. Right? There's no repeating pattern there. If we talk about pi, 3.1415 and so on, these are numbers that have no ratio that represents them, and they have a decimal that never terminates and never repeats. All right, so those are some good examples there. Non-examples would be anything that we've talked about in the sets beforehand. So 2 is not irrational, 1/3 is not irrational, 0.146 is not irrational, because all of those belong to one of the previous sets. All right. And finally, our last of all the sets for the first couple units, that is the real numbers. So R represents the real numbers, and that represents the rational set that made up all the first several sets, and the irrational set. So any real positive difference, any real negative difference, it's made up of one of these types of numbers. You can also think about this as the number line. So every number, any spot that you can find on this number line, is one of these numbers. It's a real number, it could be irrational or irrational. And so everything that we've talked about, all numbers above would be examples. So natural numbers, integers, rational numbers, irrational numbers, those are all real numbers. Non-examples are going to be a lot harder to come by, and we won't see those until much later in Unit 3. So that would be like the square root of a negative number or an imaginary number. That's not a real number. Okay, so at this point, there's just a quick review of what we're talking about above, and what I want you to do is partner up with your person sitting next to you. If you're in an A seat, the B right next to you. Partner up and work through these two examples, and then we'll come back together and check your work.